So finally, we're going to take a look at the cost of a mortgage. Under Canadian law, interest on a mortgage can be compounded at most semi-annually. This means that for any mortgage, at most, you can be charged interest twice a year or every 6 months. But in many cases, mortgage payments are made monthly. Since the payment period and the compounding period are different, we need to calculate what's called the equivalent interest rate. So we can convert the semi-annual rate to a monthly rate using the following formula. So I equals K, bracket, 1 plus S divided by 2, closing that bracket, raised to the exponent of 2 divided by K, and I recommend you think of this also as a set of brackets for that exponent, minus 1, and then close the outer bracket. Where I represents the equivalent interest rate, so depending on the question, it could be a monthly interest rate or a weekly interest rate we're looking for. And K represents the actual compounding period. So if it's monthly, the K value would be 12. If it's weekly, the K value would be 52. So let's try out this formula. So given a mortgage has an interest rate of 4.2% per year compounded semi-annually, what is the equivalent interest rate compounded monthly? So taking this new formula from above, we have the interest rate is equal to K, 1 plus S over 2 to the exponent of 2 over K minus 1. And for our example, first let's start with the K value. Since we are looking for the interest rate compounded monthly, our K value will equal 12, since there are 12 months in a year. Our S value is just our semi-annual rate, which is 0.042. Next, we sub in our values. And then finally, we let the calculator do the rest of the work. Now on your calculator, it might look something like this. So you do 12 times bracket, 1 plus 0.042 divided by 2. Close the bracket, use your exponent key, then set another set of brackets and do 2 divided by 12. Close that bracket, hit minus 1, and close the final bracket, then hit your equal sign. So using our calculator, you should end up with 0.041637. So for this example, I took 5 significant figures, the 41637. This means that 4.1637% per year compounded monthly is equivalent to 4.2% per year compounded semi-annually. So now if we wanted to figure out a monthly payment based upon a semi-annual compounding rate, we can do that using this equivalent interest rate. Example 2. The Browns have purchased a home for $400,000. They will make a down payment of 15% and then arrange a mortgage at 3.85% per year compounded semi-annually for 25 years to finance the rest. So part A, let's determine the down payment and how big of a loan do the Browns need. So first of all, they're going to put down 15% of the value of the home. So that's the same thing as taking $400,000 and multiplying it by 0.15. And if you do that, you end up with $60,000. So that's how much they're going to pay for the home initially. So we call that the down payment. So next we need to figure out how big of a loan do they require. Well, we're going to take now the $400,000 and minus the down payment. which gives us a total of $340,000 left over. So the $340,000 represents the size of their mortgage. Now that we know the size of the mortgage, we can determine their monthly payment, but first we need to find an equivalent interest rate for 3.85% per year compounded semi-annually, because again they're going to make monthly payments. So we need to convert that semi-annual rate to a monthly rate. So that's our first step. And to do that, we're going to use our formula I equals K 1 plus S over 2 to the exponent of 2 divided by K minus 1. So K is our compounding period, so that's 12. 1 plus S, well, our semi-annual rate is 0.0385 from above. And then to the exponent of 2 over 12 minus 1. And when you put that into your calculator, you end up with an equivalent rate of 0.038195. So this is the equivalent rate per year compounded monthly. So next now is to determine our regular payment for this mortgage. So R equals PV times I, because we know the present value of our loan, 1 minus 1 plus I to the exponent of negative n. And for this example, we know our present value of the loan is $340,000 from Part A. Our interest rate from the calculation above is 0.038195, but again we need to divide it by 12 because it's per year compounded monthly, so we divide it by 12. And that gives us 0.003189. Next, we determine n, the number of payments. Since we're making monthly payments for 25 years, we take 25 and multiply it by 12, and that gives us 300 monthly payments. And the next step is to sub all this in to our formula for our regular payment. So R equals 340,000 times 0.003189 over 1 minus 1 plus 0.003189, close the bracket, minus 300, and close the final bracket. So again, typing that into your calculator, we should get a regular payment of approximately $1,760.93 per month. All right, last part. How much interest did they pay for their loan? They made payments of $1,760.93 per month for 300 months. Using your calculator, you get $528,279. That's the total that they paid back for a loan that was worth $340,000. So therefore, the interest that they paid was $188,279. So this is the interest paid. So you see, for homework this time, I've made up one question here. So please try that one first. And then there are 2 questions from your textbook. Keep up the hard work. You're almost done.